All right, y'all. Today we are going to talk backflow prevention. So just to begin, let me give you the definition of backflow. Backflow, the unwanted flow of water in the reverse direction. Let me roll it back and give you some history. In 1972, Congress passed the Clean Water Act. Essentially, it regulated the discharge of pollutants into our national surface waters, including lakes, rivers, streams, wetlands, all these coastal areas. Does anybody remember the river in Ohio, the picture of the river on fire? That was literally pollutants in that water. So they passed this act to get our waters cleaned up. Fast forward a couple years, and in 1974, the Safe Drinking Water Act was passed. This was the law that protected public drinking water supplies in the nation. Ultimately, this was the birthplace for backflow prevention law. Now, I can't help but to make this a history lesson, kind of for me and kind of for you, but this is how it goes with government. We have been working on fixing water systems long before it went into law. So a real quick history. In 1906, the American Society of Sanitary Engineering was founded. Their motto was prevention rather than cure. So they were trying to get in front of clean water issues. In 1930, the very first pressure vacuum breaker was designed in downtown LA. In 1933, an epidemic of dysentery broke out at the World's Fair in Chicago, Illinois, killing 98 people and infecting 1,400 people, and it was directly related to cross-contamination between bathtubs, toilets, and drinking water. In 1944, USC's Foundation for the Cross-Connection Control and Hydraulic Research Foundation started. We were digging into these issues. In 1945, the first edition of the Uniform Plumbing Code was adopted. In 1956, the first edition of the Standard Plumbing Code was available. In the 1950s, they invented the double check valves. In 74, that Clean Water Act became a thing. In 76, American Water Works Association started the technology in that direction. In 1980, the ASSE wrote a standard for the RPZ, the reduced pressure zone valves, and we've been increasing water quality ever since. This is a big deal. Now, how is backflow created? You can look here. Example number 1, water pressure is reduced because of a break in the main line. So you can imagine you have this main line pushing water into whatever. If that line breaks, it's going to reduce pressure and draw back in. Look at example number 2. Reverse flow is created by the change in water pressure. Dangerous contaminants can be drawn into the drinking water supply through cross connection. If you had your handheld shower laying in the bottom of the tub and you lost street pressure, it could draw all that bath water back into the potable drinking system if things weren't set up with backflow preventers. Without backflow prevention, you're going to get all those contaminants into your drinking water system. That's the short of it. Now, let's look at a few devices we sell every day. So systems that are connected to the public water system must be equipped with some sort of backflow prevention. There really are 4 ways to do this. Number 1 being air gaps. Number 2 being reduced pressure zone backflow preventers. Number 3, double check valve assemblies. And number 4, vacuum breakers. Let's cover them in that order. All right, number 1, an air gap. The air gap between the public water system and any system that could cause backflow is the best method for preventing backflow. Essentially, air gap meaning there is no solid connection between point of use and the city. It can't siphon back up because there's no connection there. All right, number 2, what most plumbers are going to come in and say, hey, I need an RP device. That's a reduced pressure zone backflow preventer. This is approved in every case and in every scenario. All right, this is how it works. An RPZ has 2 check valves and a relief valve. It reduces pressure through the valve. So picture this. City water comes in one side, let's say 60 psi, and as it flows through the valve, it leaves the valve at 55 psi. If there is some sort of siphon or a reduction in pressure on the supply side, so if the city water drops below the outgoing water, it closes the check valves and dumps the water to drain. It goes through the relief valve, through an air gap to the bottom. That water can't go back in the potable side. That's it in a nutshell. Number 3 is a double check assembly. The same exact principles apply here, but there is no relief valve attached. That's the difference between a double check and an RPZ. Number 4, vacuum breakers. There are 2 main types, atmospheric vacuum breaker and a pressure vacuum breaker. The main difference is that the atmospheric vacuum breaker doesn't work against back pressure. You'll see it mostly in a faucet application. Long story short, look at a pressure vacuum breaker like this, like a check valve. You have city water pressure coming in the bottom and going out the side. If you reduce city water pressure, the check valve will close and stop any sort of anti-siphon, suck back, if you will. Whew, that's a lot of info. Okay, I'm going to wrap this up, and then I expect a whole bunch of questions. The short of all of this is backflow prevention is critical. It's very much a part of our livelihood and the life safety of so many others. Now, let's talk backflow prevention.